Hello everyone. Today we are going to test the hypothesis by using one sample t-test. So here we will demonstrate each step by using Microsoft Excel. Actually the t-tests are being used to find the significant differences between means. So here the mean parameter would be used and based on the availability of data sets so we can decide either we have to select one sample t-test, paired t-test, or unpaired or independent t-test. So now we are going to use one sample t-test. So here we are looking for the difference between the sample mean and the population mean. So here we just want to compare the mean of a sample to a known population mean. So here we just have a only one sample data sets. Like here you can see that sample data that is 9.8, 10.2, 10, 9.79. So here and the population mean is 10. So we just have to see the differences between the sample mean and with the population mean. First of all, at the initial step we just have to state the hypothesis, right? So here the null hypothesis would be the sample means will be equal with the population mean. As you know that the equal symbol will be used in the null hypothesis. And what will be the alternative hypothesis, right? So it depends upon the statement. So if there is a mention that, right, so then you can write that sample mean is not equal to population mean. It depends upon the statement. If there is a sample mean is greater than, either sample mean is less than the population mean, all of three symbols can be used in alternative hypothesis: not equal, greater, or less than, right? So here we just mention here the not equal, that means it would be a two-tailed test, right? So here we just want to be identified the mean differences, sample mean difference with the population mean. So now we are going to use Microsoft Excel to see that either we will say that reject the null hypothesis, either we will say that fail to reject the null hypothesis. In simple words, we can say that if the sample mean is equal with the population mean, if we are looking for the sample mean is not with the population mean. So here we have a data set, so we can just copy these data sets in Microsoft Excel, right? So for example, here we will just copy these values. So here you see that all of the values are in a single cell, right? So first we can convert into a column. So here you can go to the text to columns, right? So they are characters such as delimited, so next, so they are separated by the comma, okay, next, and then finish. Now you can see that before the all the values were in a single cell, now all of the values in a separate cells. So but in rows we just want to be copy, and we want to be like here transpose from row to column, right? So here now you see that we have converted these value into a column. So like this one you can move the values, so we can write here the sample data, right? So the population, and the population data is 10, right? So we can write the 10 values. Now we have a only sample and the population mean. What we have to see, what we have to see the mean difference between the sample mean and the population mean. So how we can do this one, right? So we can see that, so like by using Excel there is a no specific function for one sample t-test. So the Excel has the functions for the paired, for unpaired with the equal variance, unpaired with the unequal variances. These are functions are available in Excel, but there is no specific function one for one sample t-test, right? So the basic function is like t is equal to sample mean minus population mean divided by sample standard deviation over square root of number of sample. So first of all we will use this formula to find out all of these calculations. So here as we mentioned that either we can do all of these calculations by steps, either we can do all of these calculation in a single step. So this is the formula to find out the t value first, right? So it first x mean, that is like for this sample mean. So here in the sample mean, so how we can find this sample mean? So like sample mean that can be find like here the average, right? And then we can select these of values, and then so here we can get the sample means, right? So before we have a sample values, n is already mentioned that 1 to 10 values. The population mean is already available, we just have to see the sample mean and then standard deviation, right? So we can also find the standard deviation. So here we can find the standard deviation. So here we will select these values. So here we have found the standard deviation and the sample mean. And right now we have the values. So by one, if we find that sample mean with the population mean, right? We can write like this one. So first we see that the sample mean minus with the population mean. So we can select this sample mean, this one, and minus the population mean is 10, right? So this one, and then we can find s divided by square root of n, right? So how we can find? So here we just have to find the first standard deviation values divided by square root of. So what is the n? N is total number of values are 10. So this is the first numerator and this one is denominator, right? And the total, the t value would be, so can we do this one first? Select this one and divide by with this value, right? So this will be the t value. Now we have found the t value for this one, and here we are using for the p value method. We will decide that either we are going to reject the null hypothesis, either we are fail to reject the null hypothesis. To find out the p value, so first of all we have to see that either it is one tail test or two tail test, right? So if there will be not equal sign is used in alternative hypothesis, that means it is the two tail test, because we are not sure about which direction we have to see. So for that p value we just have to find by t distributions, right? So here there is a specific functions for two tail test and right tail. So here it is mentioned the not equal symbol, so we can decide, so it is two tail test, right? So here we can see that minus negative symbol is used. So first of all, so we write absolute. That mean in absolute, the meaning of this one, it will not consider the negative values. So if we not use absolute, that means so then don't use the negative signs. So we will also try this one. So absolute of this value, right, parenthesis, then it will ask you for the degree of freedom. Degree of freedom is always n minus 1. The n is total 10 and degree of freedom will be 9, right? So then we will click. So this is p value for the two tail test, right? P value for two tail, right? I have mentioned just two. So here the p value is 0.41, right? So if you see that if p value is greater than the significance level, that is 0.05, so what we have to see? So we can say that fail to reject the null hypothesis. That means, so there is a no significant difference between these means. So if the p values always be less than 0.05, the significance level, we can say that that means there is a significant mean difference between the population mean and sample mean. Here it value is always also greater than 0.05. So we can say that fail to reject the null hypothesis. That means in simple words we say that null hypothesis is true. The null hypothesis was sample mean is equal to population mean. That means there is a no difference, right? So I will just also tell you, if there is a, here in this example this is for two tail, right? If you are looking for the p value for one tail, so how you can do this one, right? Same. So this one, right? So same, we will use absolute values, and then the value is the t value, degree of freedom 9, right? So here this is the value of p value for one tail, right? So here you can also see that, so this p value is also greater than 0.05 significance level. So we can say that fail to reject the null hypothesis if it would be a one tail test, right? So I will also here show that, so what is the function of, for example, so what was the function of absolute? If we don't consider absolute, that means we don't have to use negative symbols. So what is the value of that? 0.85424, right? So absolute values, we consider absolute, that means it will not consider the symbol if it is the value is in negative. So here, and degree of freedom 9, so value is, both are same, right? Here this one is same, but here we have used absolute value, absolute in function. Here we didn't use the negative symbol, so that means it will not consider negative symbol if we will use the absolute values, because we are just considering, we are looking for the p value, right? So one thing we have found, that we have concluded the hypothesis, that means fail to reject the null hypothesis, right? The second option is that, like if we are, the second method is critical value method. If we see that the t value is greater than the critical value method, that means we will say that reject the null hypothesis, right? So how you can do the, we can find the critical value, right? So we can find the critical values, then we can decide either the value is in rejection area, either the values are in the boundary of the critical regions. So for that one, so it is t inverse, right? So here same, so either we have to use for two tail test or single tail test, right? So here for the two tail test, so you know that if there is a two tail test, so we will write the significance level, that is 0.05, right? And again we have to mention degree of freedom, that is 9, right? So the value is 2.26, right? So here you see that what is the t value in negative, right? So you can also find if it is t inverse, right? So if you have to see that either you are looking for the right tail test or left tail test, right? If that is only one tail test, that is the right tail. That means we are looking to the right side, not to the left side. So for that one, you just have to the total area minus with that, right? Minus with this one, and then degree of freedom. And this is for right tail, right? So this is for right critical values toward the right tail. Okay, so if we are looking for the left tail, that means we are just looking for the left tail. So the same 0.05 and degree of freedom is 9. Okay, so you can see that the same, the right tail the positive 1.8, and here the left tail, so minus 1.8. Okay, so as we know that, so from our statement it is, so we are not sure, we both have to see on the both tails, right? So if our values, the critical values on the positive side is 2.2, right? If the our curve is right? And this value is less than this value, the positive sides, and here in left tail test, so minus 1.8. So that values are in between. That means the area, it doesn't fall in the critical regions. That means we can say that fail to reject the null hypothesis, right? So as I have mentioned that, so here, if you see that, compare your t value. If it is greater than, you can reject, but it is not greater, it is less than 2.2, right? Your t value is actually minus to 0.85. So if it is minus 8, so we can also say that the values in between that, not in the critical region. So we can say that fail to reject the null hypothesis, right? So that was the basic actual the formula how you can test the hypothesis by using one sample t-test by using Microsoft Excel, right? So here, first we have found the t-value, then by using the p-value method we test the hypothesis, then by using the critical value method we have tried to find so what is the conclusion of this hypothesis, right? So another option is that, so the third one, so in the data analysis, right? So if like this option is not enabled in your system, then you can go to here the options, right? Add in and manage add-in. Then here you can just check this analysis tool back, right? Then this option will be appear here, right? So here you go to the data analysis. So here you can see that t-test paired two sample for means, two sample assuming equal variances, two sample assuming unequal variances. You can find that here there is nothing for one sample t-test. Okay, so can we try to find some close values by using two sample assuming equal variance? Here we just assume both of them are equal variance, right? But here we have to mentions the two variables, but here we only have one variable. So first we can create with the dummy variables, like we can use the same the population mean, right? Now we can say that both of them are, we can say that dummy, right? So then we can select two sample assuming equal variance. The here you can select the first one as a first value and the second with the second. Okay, so mean difference, we see that the mean difference is 0. Labels, we didn't select these ones, so we will not check this option. Significance level is 0.05, and where you want to be, highlight this option. So output, if we select here, okay, so then you can find the results here. Okay, so here the variable 2, that was the totally dummy. So if we delete, so there will be no effect, right? Now we can see that the mean is 9.94, the same mean what we have found, right? Okay, and observation, that is sample size is 10. So here we just see that what is the t value, right? So what we have found by the this formula, the t value that was minus 0.85. So here the t value is also same. Okay, okay, so what is the p value if there is a one tail test? So here we also try to find out the p value, that is also same 0.2075, right? Okay, so you can conclude the hypothesis if it is only one tail test by using this p value. Okay, and the p value for two tail test, that is 0.401, right? So here we have found that it is also close to that 0.41. Same same we can say that conclude fail to reject the null hypothesis because it is exceeding to the significance level. And here you find the critical region for one tail is 1.73. Okay, that is also close to the this 1.8, right? For the two tail test, that is 2.1, so it is also 2.2. So here, because we were using the dummy values, so it has little bit effect, but actually this method is for two samples, not for the one sample here, but we can use just to estimate, just to find the close values. But actual the authentic ways, we can use this formula to find out the actual values of the t value, then we can use that specific t value for the two tail test or for a one tail test, right, to find out the p value, and then we can conclude with the hypothesis, right. And similarly we can also find the critical value method by t inverse formula if it is one tail test or two tail test, and then we can also decide. So here we can say that from the both of the methods, p value and critical values, so we can say that this is, we can say that fail to reject the null hypothesis, right. So here you see that we have used t-test to sample assuming equal variances, so we can use this one by formula, right, t-test. So t-test, so it will also ask you about two variables range, two data sets, right. The first one we have selected for this one array 2, that we have selected dummy values, right. Then so here it will ask you about one tail distribution or two tail, right. Two tail distributions that not equal symbol was used in alternative hypothesis, right. Then it will ask you about the paired two sample, right. Here it is also the paired, that means it also requires two sample data set, right. So we use two sample equal variances, so we can choose this one, right. So here we have found the p value, we can directly found the p value for this data set, right, the same as we have found from here. But actually, so it's better like first we can use this one to find out the p value critical values method, and then you can state the hypothesis, you can conclude, and just to verify your results, then you can also try with this one, right. So here we can say that we can test the hypothesis by using Microsoft Excel, by all of these method by using Microsoft Excel, and then you can conclude that. So either you will decide reject the null hypothesis, either you will say that fail to reject the null hypothesis, right. I hope you got all of these things. If you have anything questions or any comments, you